Hi friends, so in the previous video we saw that the formula of curvature was given by this term here, and then I just said that this is also the divergence of negative of the divergence of delta phi by the magnitude of delta phi, but I did not show that how this divergence was calculated. So that is what we'll do in this video. So let's get started. So the divergence of delta phi upon the magnitude of delta phi is given by something like partial with respect to x of phi x by under the square root of divided by the square root of phi x square plus phi y square, which is the magnitude. And there is a similar term with partial with respect to y. It will have phi y instead of phi x. Everything else is same, so I'm not going to write that. We'll solve this term and then we'll uh, like form that term by interchanging x's and y's. So this is what we want to solve for. So this is basically we'll have to use the chain rule. So that's given by phi xx upon, I'm just going to write this in shorthand, del phi, and then for the next part of the chain rule we have to take the derivative of that square root, so that will be minus half, and then the shorthand it will be 3 raised to 3 by 2, but if we are writing it as this then it's just this cube, and then we already have this phi x, and then we differentiate inside the square root. That will give us 2 phi x, and this should be around everything, phi x phi xx plus 2 phi y phi yx. Yes. So now taking the least common multiple, we get phi xx, and of course there is the y term which I'm not writing, but I'll add it later. Phi x square plus phi y square, just taking the least common multiple, negative, and the 2's get cancelled out. Now we have phi x square phi xx and the negative of, I'll write this here, or I can do this maybe, uh, 2 phi x phi y phi yx. And now as you can see, this term here and this term here gets cancelled out, so what we are left with is phi xx phi y square, um, and then the negative of 2 phi x phi y. Oh sorry, that 2 is not here because even that 2 got cancelled out. uh, Phi x phi y phi yx, and don't forget the whole thing we took the least common multiple is divided by del phi magnitude cube. So this, and also don't forget there is a j term to it. Sorry, not a j term, like the partial with respect to y. This is that. So now we can add that partial with respect to y. It's going to be the same except the x's and y's are going to be interchanged. So this will be phi x phi y, and this can be written as phi xy. Actually it's the same thing, if doesn't matter what you differentiate with respect to first. And then adding the j term, that would be, sorry, the partial with respect to y term, that would be this minus phi x phi y phi xy. And now you see where this is going, hopefully. So then what we have, this is what we started with, phi xx, phi y square minus 2 phi xy, phi x, phi y plus phi yy, phi x square upon the magnitude of this. So this is what we wanted to show, that the divergence is given by this formula, and that is exactly what we showed. We started with divergence here, and that's why we know that these two things here are equivalent and they give us the same formula, which is given by this here. So yeah, that's all I wanted to show, that the formula we derived is the divergence. So with that we know what the curvature of the level set is. So thank you.